right, chapter 3, section 3.1, quadratic functions. And it says right there, we start in section 1.5. In section 1.5, we studied quadratic equations. And so we just want to quickly review some of the things we learned there, because there will be a lot of carryover into this section. Recall, a quadratic equation has this form right here, ax squared plus bx plus c, where a does not equal 0. So what that is telling me is a quadratic equation is going to have that exponent of 2 as its highest exponent. Degree 2. Degree is your highest exponent. It also has no variables and radicals or denominators, no negative or fractional exponents, but we're not going to try to trick you or anything. X squared as the highest exponent. And when we were solving quadratic equations, we had 4 principal means of solution. We had factoring. Factoring works really well if you can factor it. It doesn't work at all if you can't factor it, and not everything is factorable. The square root method, that worked really well if you could rewrite the equation, a square term equal a number. But if you couldn't rewrite a square term equal a number, again, didn't work at all. Completing the square, we actually didn't discuss that, but it's an option if you remember it. And for some of the applications in this section, there are some teachers that teach, do it by completing the square. Yeah. We're not going to do that, but it's just listed there for completeness sake. And completing the square can always work. It may always be used to solve a quadratic equation, but students don't like it. It can give nasty numbers, and that's why I chose not to cover it. And then lastly, the quadratic formula. It can always be used. It's prone to stupid mistakes. And then I want to make a comment about both factoring and quadratic formula. Remember, both of those you have to have it set equal to 0. The quadratic formula is only valid for quadratic equations equal to 0. And the factoring thing, the part where we split the equation up into separate equations, only true if it's equal to 0. So that's stuff that we learned in 1.5. But really what I want to emphasize here, this is important here, but when we're talking quadratic, you've got that x squared there. So in this section, instead of calling them quadratic functions, or quadratic equations, we're going to call them quadratic functions. Quadratic function has the form a times x minus h quantity squared plus k, for a not equal to 0, or x squared plus bx plus c. Both of those are 2 different forms of quadratic equations. Now note here, if you were to FOIL this part right out here, the x minus h quantity squared, if you were to FOIL that out, you'd have that x squared again. So again, we're looking for that highest exponent as the 2. There cannot be any negative or fractional exponents, no variables in the denominators. And we learned earlier that the basic shape of the graph x squared was called a parabola. The line that happens to divide that parabola in half, this line right here, and it doesn't have to be the origin, doesn't have to be the y-axis, but the line that goes down the middle of the parabola, that's called the axis of symmetry. And in this case, it happens to be the y-axis, but it certainly doesn't have to be the y-axis. And the point that's either at the very bottom or very top, as the case may be, that's called the vertex. In this case, my vertex happens to be a minimum. If my parabola goes the other way, the vertex would be a maximum. So we're going to talk about quadratic equations in both of these forms. And we're going to start with what is referred to as standard form. F of x equals a times the quantity x minus h quantity squared plus k for a not equal to 0. That's in standard form. Then we have these facts right here. The vertex is the point hk. Notice the opposite of whatever's inside the parentheses. So this says minus h. I'm going to zoom in just a little bit. This says minus h, so my vertex is h. And this comes, the opposite thing comes from when we learned about horizontal translations. That when we were doing horizontal translations, the left-right movement, it was always opposite to what you expect. that if it was subtracting, you went right, and if it was adding, you went left. You did the opposite when it was horizontal translations, when you were looking at a number inside, in this case the square, it was opposite, and that's carrying over here, that the vertex is going to be the opposite of what we have in there, h, and then just the number k on the end. So the vertex is hk. If a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. The axis of symmetry is x equal h. Now, instead of memorizing that, another way of saying that is x equals the x coordinate of the vertex. Is all that is ever saying about the axis of symmetry. That'll be x equal the x coordinate of the vertex. The x-intercepts are found by solving f of x equals 0, or that is, set the function equal to 0 and solve. And that's the easiest way to remember it. X-intercepts are found by setting the function equal to 0 and solve. Note, not all parabolas have x-intercepts. If when you solve f of x equals 0, you get a non-real solution, that means there are no x-intercepts. Now here it says the x-intercepts are found by setting the function equal to 0 and solving. That is certainly true, but it's true for more than just parabolas. For any function, if you want to find the x-intercepts, you set the function equal to 0 and solve. And for any function, if you get non-real answers, that means there are no x-intercepts. That when we are talking things graphical, x-intercepts, things graphical, we are not going to use imaginary numbers. So if you set the function equal to 0 and solve, and you get, say, for example, an answer of 2i, that means there are no x-intercepts. And lastly, the y-intercept is found by finding f of 0, or that is by substitute in x equal 0. So there are the things we need to remember. To graph, find the vertex, x and y intercept, plot these points, and then sketch a parabola in the correct direction through these points. And so let's use these facts now. Use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry. Use the graph to determine the function's range and domain. Okay. So we're just going to start finding pieces of information, and in the end, we are going to graph it. So the vertex, since it's in that standard form, we can just read it right off. -3, -6. Opposite of the number inside, number on the end. That's all we have to do for that. Y-intercept. And not doing these steps in any particular order, just whatever's coming in my head here. Y-intercept, always substitute in x equals 0. So y is going to be f of 0, which will be -2 times 0 plus 3 quantity squared minus 6, which will be -2 times 3 squared minus 6, -2 times 9 minus 6, and what? That's going to be -18 minus 6, -24. And if you wanted to be a perfect student, and I wanted to be a perfect math teacher, we would say it's the point 0, -24. I do believe the computer asks you to type in this case, -24. But if anyone or the computer ever wants a point, it's the point 0, -24. That when you're doing intercepts, the other coordinate is always 0. Here we're doing the y-intercept, so the x-coordinate would be 0. The x-intercepts now, set equal to 0 and solve. So -2 times x plus 3, quantity squared minus 6 equals 0. And then you solve it in whatever appropriate way whatever appropriate way. In this case, notice, because I have something squared, it's a strange square, but something squared in just numbers, since it's just squares and numbers, I can do the square root method. So that's going to be -2x plus 3 quantity squared equals 6. Divide both sides by -2. So let's go up here and finish that. So that's going to be x plus 3 quantity squared equals -3. And now that I have square term equal a number, that's now perfect for the square root method. And remember, hugely importantly, when you're doing the square root method, you've got to put in that plus or minus. Whenever you're solving an equation and you take an even root of both sides, you include that plus or minus. But I can get right here and I can pretty much stop. That's an imaginary number. And what we said on this page back here, if you get a non-real solution, that means there are no x-intercepts. So no x-intercepts. It also asks for the axis of symmetry. So we have room here for that. Axis of symmetry. That's always x equals the x-coordinate of the vertex. So in this case, x equal -3. Now we haven't finished the problem yet, I've run out of room. And we will check it here, but now going on to a blank piece of paper and actually graphing it. So up here we'll read the instructions again. It says use the vertex and intercepts to sketch the graph of the quadratic function, give the parabola's axis of symmetry, use the graph to determine the function's domain and range. The reason why I read it again, use the vertex and x-intercepts to sketch. When you go and do this work on the computer, you can give it an absolutely perfect graph, but if you didn't use the vertex and x-intercepts to make the graph, it will count it wrong. So be sure when you're doing your work on the computer, when it says vertex and x-intercepts, use the vertex and x-intercepts. Okay, so now graphing this guy. To graph. And we have f of x equals -2. Didn't write -2 there, I wrote 3. We have -2 times x plus 3 minus 6. In this case, that a value we talk about is -2, which is less than 0, so that tells us the parabola opens down. And then we know also that the vertex was -3, -6, and the y-intercept was -24. So now we just want to put that onto a picture. -3, and then -6, and let's call that -6, -12, -18, -24. You know, graph appropriately. So there's my vertex, there's my x-intercept. We know the parabola opens down, and then you just do your best to draw a parabola opens down. I minced my x-intercept a little bit, so we'll just make the point bigger. And there's my graph. Now they ask us for one last piece of information, the domain and range, which we will get on the next video. So there's a little cliffhanger. What's the domain and range going to be?